Hi, my name is Aiden Benderly.
And my name is Dhruv Mehta.
We're students at the Middlesex County Academy for Science, Mathematics, and Engineering Technologies.
We're both part of the Electrical Computer Engineering Technologies track.
Under the instruction of Mr. Enzo Paterno.
And this is our senior project. As part of our senior year, we have to solve a real-world engineering problem. The problem that we noticed was that in large study halls or in research classes where our students have earbuds in and listening to music or watching a video, the teacher has a really hard time getting the attention of their students. Let's say the teacher needs to send a student to the office. It's going to take a long time if they have to get up and walk over and actually physically move the student before they can hear the teacher.
The solution to our problem is our product VANS, which stands for Voice Activated Notification System. Our product consists of two parts, a teacher device, as well as an Android app. When a teacher needs to get a student's attention, they'll push a button on the teacher device and then speak a student's unique number into the microphone. The student will then receive a notification on their Android. This is the conceptual diagram that we created in the first marking period for our project. The black is what you see is the box, and the white is where the screen goes. The screen was designed to be at a 30-degree angle, which we decided was the optimal angle for a person sitting down at a desk.
This is a block diagram of our product. As you can see, the main component is the Raspberry Pi 2 Model B, which is powered by the 5-volt 2-amp supply. It hosts our speech recognition and database. The speech recognition gets its input from the microphone interface, which is comprised of a USB microphone and the button on the printer circuit board. The database is displayed on the output screen. The output screen is connected to the Raspberry Pi using an HDMI connection, and it is powered using a 12-volt 2-amp supply. The Raspberry Pi also hosts a Flask web server, which is used to communicate with the Android app.
Here's a demonstration of our project working. This is the register page located on the Android app. You'll type in your name, as well as the teacher IP address. When you're done, you'll press the register button, and when it successfully goes, you'll get a notification on your phone that you've registered, as well as show on the teacher device that the student has registered, along with all the other phones registered. We will now demonstrate a teacher calling a student. I'll demonstrate this with the orange phone, which is student 3. To call a student, a teacher will push a button on the side of the box and then wait for a command that says to speak. This teacher will then say the word student followed by the number, in this case 3. Student 3. The device will then show that the orange phone is called, and the orange phone will receive a notification. The notification will vibrate the phone and play a voice message which tells you to go see your instructor. It will also show a notification in the notification bar. Now, I will demonstrate this with the red phone, which is student 1. Student 1.
Please go see your instructor. He or she requires your attention.
And as you can see, the notification shows up. Lastly, we'll show the black phone, which is student 2. Student 2.
Please go see your instructor. He or she requires your attention.
When students are playing music, our app will automatically fade out any outside sounds before playing the notification. I will now demonstrate this using the last phone. Student 4.
Please go see your instructor. He or she requires your attention.
As you can see, the music faded out first before playing this notification, and the swipe notification appears as well. In the event that the student needs to leave the room or the class ends, the student can leave the database by pressing the Leave button. As you can see, the student will then disappear from the database.
In addition to its current use in the classroom setting, our product can be expanded to a multitude of different areas, including large waiting spaces and office areas. A prime example of this would be used in a restaurant setting, where patrons often wait for long times before getting their tables. Currently, they use a buzzer system where they hand out buzzers which then ring when their table is ready. But using our product, patrons could subscribe with their individual devices to a central device located with the waitstaff. The waitstaff would then be able to use this device to call the patrons when they're ready. This would dramatically cut down the operating costs of restaurants, as they no longer need to maintain a buzzer system as well as its hardware.
In the future, we can minimize costs by replacing the teacher console we have right now with a teacher-specific Android app. The Android app would host a database just like the teacher console and also host a speech recognition program for when the teacher wants to call a student. We will now delve into the technical details of our product.
This is a picture of the printer circuit board that we designed and had printed by Advanced Circuits. The part that you see missing is the part that is actually inside of the device, and the rest are copies in case one part was defective. As you can see, there is a slot for a button, which we designed as active low, a resistor, and a ground and power pin, as well as a signal pin, all of which connect to the Raspberry Pi via the GPIO pins. The speech recognition software is run through a Python API known as Jasper. The Jasper API records an audio file and then sends that file to Google for the speech recognition. The Google Speech API takes the speech and transcribes it into text before sending it back to the Jasper API located on the device. Once the text is back, we have written a module which parses that text for the word student, as well as the number that follows right after the word. When the number is taken in, that number is associated with the student as well as the student's MAC address. The MAC address is then taken and placed into a separate notification table in the database. We used a Python API called SQLite to create our database. The database contains 3 tables. The student table, which contains a number, student name, and MAC address for each student. A message table, which is used to transport messages from the Jasper API to the GUI, as well as a notification table, which is used to transport the MAC address of the called student from the Jasper API to the Flash server to be sent to the student. The GUI, which was made using tkinter, displays a student's name and number as taken from the student table. We used a Python API called Flash to set up a server on our Raspberry Pi's local IP address. How it works is that the Android will send an HTTP GET request to a specific URL containing the IP address, the name of the function, and any variables we want to pass to the function. When this ping is successful, the function will be triggered on the Raspberry Pi side. The first function is a register function. The Android app will send a name and MAC address up while calling this function. The Flash server will then receive this information and store it in the student table in the database. The next function is the polling function, which is pinged by the Android app continuously on a designated time interval. The Android app will also send its MAC address up every single time. When this function is triggered, the Flash server will compare the MAC address sent to it with the MAC address in the notification table of the database. If the two match, the Flash server will let the app know that there's a match and then delete the MAC address from the notification table to prevent multiple notifications from being sent. The last function is the leave function. When the Android app triggers this function, it sends up the MAC address with it. The Flash server will then look in the database and delete the entry which matches that MAC address, removing the student from the database. The Android app coded in Java uses the OK HTTP API to send HTTP GET requests to a page on the server. When this GET request is successful, the function on the Raspberry Pi will be triggered. When the server lets the Android app know that there was a match in MAC addresses, it triggers the notification using the Notification Manager class provided by the Android framework.